So today I'm going over a parallel circuit. You can see that my parallel circuit has 5 volt supply, has 4 resistors, 400 ohm, 1.2 kilo ohm, 600 ohm, and 2 kilo ohm. I'm going to solve this circuit. This is an example from my digital electronics class. When I solve a circuit, I use a guess technique. The first letter in guess is G, and we're going to use that for our givens. So our givens are, of course, that our voltage total equals 5 volts. We also know the size for each of our resistors. Resistor 1 equals 400 ohms. Resistor 2 equals 1.2 kilo ohms. Now, even though it's kilo ohms, remember when you go ahead and do calculations that you actually need to convert that back to the base units, so that'd be 1200 ohms. Otherwise, your calculations will not work. Resistor 3 is 600 ohms, and resistor 4 is 2 kilo ohms. Once again, remembering that we'll have to convert that back to 2000 ohms before we actually do the math. The next thing in guess is a U for unknowns. So if I put a U here, we do not know our resistance total, so RT. We do not know our current total. Then, remember, in a parallel circuit, voltage stays constant. The voltage throughout this entire circuit is going to be 5 volts. The thing that changes is current. So we're going to have different currents at each resistor. So we can go ahead and also look for our current at each resistor. So current at resistor 1, current at resistor 2, current at resistor 3, and current at resistor 4. And that should be all of my unknowns. The next step is going to be E for equations. So I'm going to go ahead and write that up here. E for equations. Of course, we're going to use the general equation, V equals IR. So V equals IR, that's the format I like to use it in, and we can go ahead and change that into whatever format we need. The next equation we're going to use is to find out our total resistance. So RT equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on, however many resistors we have. So far we've done G, U, E. Now the S and the S on guess are for substitute and solve. I like to put those together into one step. I think it's easier than having to go back once we substitute and then go ahead and solve all of them. So S is going to be my last step in my guess technique. In this, what I'm going to go ahead and start out doing is I'm going to find my resistance total first. So I know that my resistance total equals 1 over resistor 1, which is 400 ohms, plus 1 over resistor 2, which is 1200 ohms, plus 1 over resistor 3, that is 600 ohms, and resistor 4 is going to be 2 kilo ohms, or 2000 ohms. Now that might be a little small to see, but I went ahead and told you about it as I was doing it. I can draw this equation on out here. If you go ahead and have a standard scientific calculator, you're probably going to have an x over 1, or a 1 over x, or an x to the power of negative 1 button on your calculator that you can use for this. So if I'm using that button, I go ahead and type this in the calculator. It makes it real easy. 400, I have a 1 over x button, so I hit 1 over x, plus 1200, 1 over x, plus 600, 1 over x, plus 2000, 1 over x, equals, and then once I have that, it comes out to 0.0055. So if you're doing this, you might get that same number. I still have to invert that again. Let's take care of this up here. So if I go ahead and hit that 1 over x again, I find out that RT equals 181.8181818181, so on, and that's going to be in ohms. Something you will notice with parallel circuits your total resistance is always going to be less than your smallest resistor. So if I would have found that my total resistance was over 400 ohms, we'd know that we had a problem and we'd have to double check things. Now that I have that answer, I'm going to go ahead and write it down into my unknown list. So I'm going to go ahead and put that right down here. Resistance total equals 181.81 ohms. The next thing I'm going to solve for is current total. I have my voltage total, I have my resistance total, so I should be able to use my V equals IR. Voltage total equals current total plus, times resistance total. And I can fill those in. 5 volts equals, my current is what I'm looking for, so IT times 181.81 ohms. If I go ahead and divide my 5 volts by that 181.81 ohms, that should give me my current total. So I'm going to take 5 divided by 181.81, and I find out that my current total, IT, equals 0.0275. I'm going to go ahead and round it off there, and that's measured in amps. When I go ahead and bring that back over to fill in my unknowns, I'm going to go ahead and use SI prefixes, so I like to have a number in front of my decimal. You can notice I'm going to have to move it 1, 2, 3 places to get numbers in front of my decimals. Always has to be a multiple of 3. I had to move behind the decimal or beyond the decimal, so to the power of -3 means we're going to have milli. So let me get my blue marker again so it stays consistent. And this is going to convert to 27.5 milliamps. Now that I have that, I can go ahead and start solving. I don't really need that to solve the other currents, but I can go ahead and start solving the rest of my currents. All of my currents are going to use that same V equals IR equation. So I'm going to go ahead and come up here and start solving for different ones. I'm going to deal with resistor 1 first. We know V equals IR. I know that my voltage everywhere is 5 volts. And then my current is what I'm looking for. And each of my resistors I can plug in. So resistor 1, I'm looking at current at resistor 1. So resistor 1 is 400 ohms. And once again, I go ahead and take 5 divided by 400 is going to give me that number. 5 divided by 400 gives me I at resistor 1 equals 0.0125. So once again, I could go ahead and put that number over in my answers. I'm going to go ahead and move 3 decimal places again beyond the 0, so I'm going to be dealing with milliamps again. I should label my answer up here. That way we have all of our answers. And over here, that's going to be 12.5 milliamps. We're going to go ahead and continue on down the list. We can go ahead and do resistor 2, 3, and 4. They're all going to keep the same voltage. So I'm not going to worry about rewriting my equation. I'm going to just say 5 volts equals current at resistor 2 times its resistance, which is 1.2 kiloohms. Notice that I need to actually change that to 1200 ohms. Otherwise, it's not going to calculate out right. I need to take it out of its SI prefix. So if I take 5 divided by 1200, I find that my current is equal to 0.00417. Approximately. I went ahead and rounded that off. I can write all these in when I'm done. I'm going to go ahead and do the other ones while I'm over here on the screen. So 5 volts equals current at resistor 3 times its current is, or its resistance is 600 ohms. And once again, 5 divided by 600 gives me a current at resistor 3 equal to 0.00833. The last one I'm going to have to go ahead and do is my current at resistor 4. So 5 volts again equals current at resistor 4 times 2,000 ohms. Notice once again I took it out of kilo ohms to 2,000 ohms. And once again I take my 5 volts divided by my 2,000 ohms. And I find that current at resistor 4 equals 0.0025. Now I have to make sure to label all my answers, because a non-labeled answer isn't going to do me any good. I don't know the units I'm dealing with. Now that I have all of those there, what I'm going to go ahead and do is I'm going to write those down in my unknown list. I could have gone ahead and done them each by one, but I didn't want to take the time to pan the camera back and forth. So looking at resistor 2, I'm going to once again use milliamps, so I move my decimal place 3 places, and I end up with, let me go ahead and erase that and start back on that. Resistor 2 is 4.17 milliamps. Resistor 3, once again moving it 3 places, is going to give me 8.33 milliamps. And resistor 4 is going to give me 2.5 milliamps. Now, we've solved for all of our unknowns. One thing we're supposed to go ahead and do next is use Kirchhoff's law to go ahead and double check our answer. In series, Kirchhoff has a voltage law which says all the voltages at the different resistors add up to the source voltage. In parallel, Kirchhoff's law says that all the currents throughout the resistors have to add up to the total current. So what we're going to do is we're going to add all of our currents. Since all of them are in milliamps, we can leave them in that unit, and we're just going to go ahead and take 12.5 milliamps plus, we're going to add all these together, so I've got plus 4.17 milliamps, and I've got 8.33, and the last one should be 2.5. If I add all those together, hopefully they will come out to my 27.5 or close milliamps. So 12.5 plus 4.17 plus 8.33 plus 2.5 gives me exactly 27.5 milliamps. Now, that proves with Kirchhoff's law that we did our math correctly. Something to note is if they were not all milliamps, if we had some that were amps, some that were microamps, milliamps, different things like that, you would want to change them back to that base unit before doing the math. So up here you can see once again my example of how to work through a parallel circuit, showing all the work as well as Kirchhoff's law at the end there. I'm going to go ahead and pan across all of the different things, taking a little time so you can see my work. Hopefully that's helpful as you do your work.
YouTube.com/BeesHelp. Woo!